In this video we're going to look at the ionic product of water, Kw, try and explain that, and then look at how this is useful with working out the pHs and calculations to do with strong alkalis. To start with, let's look at this first sentence, that pure water ionizes to a very small extent. What do we mean by that? Well, here's a water molecule, and when this ionizes or dissociates, one of the oxygen-hydrogen bonds will break. What will that make when this happens? Well, the electrons are going to the oxygen, which will leave us with the hydrogen ion as well as hydroxide ions. Hopefully we can see that when that takes place, the amount of hydrogen ions that we've got and the amount of hydroxide ions will be the same. But just for pure water, to put things in perspective, it doesn't happen an awful lot. So the amount of water that we've got left at equilibrium is huge, and the amount of hydrogen ions and hydroxide ions, remember they're the same, but they are tiny. As we can see, this process is an equilibrium, so it brings in another equilibrium constant. This time, to do with water, we're going to call it Kw, and this is a measure of the concentration of the reactants over the product. So we're probably going to expect to see Kw written like that. However, since the amount of water, the concentration of the water is huge, as we've said, that basically means that the water doesn't change in this expression. It's effectively a constant, and so we can remove it from the Kw expression, just like that. So we're going to write our Kw expression just simply as the concentration of hydrogen ions multiplied by the concentration of hydroxide ions. Just like that. The dissociation of water is an endothermic process. Why is that? Well, remember what was happening when water dissociated, so it was a bond breaking process. So bond breaking requires us to put some energy in. And when we increase the temperature, equilibrium will move to the right hand side, so Kw will increase. So what is the pH of pure water at 298 Kelvin? Well, we may well know this. The value of Kw, that will be given in the question, so that's going to be 1 times 10 to the minus 14. It's a very small number because the amount of dissociation is so slight. Since these are the same, that means that Kw is equal to the hydrogen ion concentration squared, which means the hydrogen ion concentration is the square root of Kw, which is the square root of 1 times 10 to the minus 14, which is 10 to the minus 7. Remember, pH is minus log of the hydrogen ion concentration, so if you do that on your calculators, minus log of 10 to the minus 7, and hopefully not too many surprises, we've just proved that water at 298 Kelvin has a pH of 7.